In this video, we're going to look at how to draw a graph from a given equation. So, in this example, we're going to draw the line y equals a half x plus 1. And I've drawn a quick table of values to help us to do this. This is probably the easiest way to understand this. So, this is going to help us to work out coordinate points that are on this line. So, if I put in x equals 0 into the equation, well, a half times 0 plus 1 is going to be 1. And 1 times a half plus 1 is 1.5. And 2 times a half plus 1 is 2. And 3 times a half plus 1 is 2.5. And so on and so on and so on. 6 times a half plus 1 is 4. So what this is doing is creating coordinate points that we definitely know is on our line. So if we start to mark these onto the grid, we're going to see where our line's going to go. When x is 0, y is 1. And when x is 1, y is 1.5. When x is 2, y is 2, and so on and so on. When x is 6, we have that y is 4. So all we then need to do is mark a few points on, and then we can join them up to create our line. So there it is, that's the line y equals a half x plus 1. Now, carrying on, let's look at a more complicated example. This one involves some negatives as well. Now, we're not going to be able to fit all these points on our graph, but we'll do our best to work out a few points here. We need about 3, and then we can join them up to create the line we need. So first of all, let's look when x is 2, shall we? So when x is 2, y will be 2 times 2 take away 1, which is 3. So we can write that in there. When x is 0, we'll have 2 times 0 take away 1, which is minus 1. When x is minus 2, we're going to have 2 times minus 2 minus 1, which is minus 5. So there's 3 coordinate points we've generated. Let's mark those on. So when x is 2, y is 3 is there. When x is 0, y is minus 1, which is there. When x is minus 2, y is minus 5, which is there. So then we can join these up with a straight line, and we can extend that line on as well through our axes, and that is the line y equals 2x minus 1. Now, all these lines have different steepnesses, and the steepness of that line is known as the gradient. So the gradient, the definition really, is the change in y divided by the change in x between any 2 points. So let's have a look at what the gradient of this line is. Well, we've taken this point here and this point here, and if we look, the change up, or the change in y, is 4, and the change across, that's the change in x, is 2. So the steepness, or the gradient of this line, is 4 divided by 2, which is of course 2. This line has a steepness of 2. Let's carry this on then and look at some other gradients of these lines. Well, in part A, the change up is 4, the change across is 1. So we've got 4 divided by 1, which is 4. In B, the change in y, it goes up 4 divided by the change in x, which is of course 4. So that's going to give us a gradient then of 1. In C, we've got a change up of 5 divided by a change across of 1, so that is a gradient of 5. In D, we have a change in y going up, and you can see it there, look, of 4 divided by a change across of 2, so that gives us a gradient of 2 when we divide 4 by 2. In section E, we've got a height there, a change in y of 6, and we've got a change in x between the 2 points of 4. So we've got 6 divided by 4 is 1.5, and there's our gradient for that line. In F, the change in y between the 2 points is 5, and the change in x between the 2 points is also 5. So 5 divided by 5 is 1. And notice that the line here in B and the line in F has the same steepness, and this is therefore the same gradient of 1. In G, we have a change here of 5 going up and across going 2, so that's 5 divided by 2, which is a gradient of 2.5. And of course in H, what's the gradient? Well, there's no change going up at all, so we'd say in this case that the gradient is 0. Okay, that completes this unit. Good luck, you can do the exercises now.